Hello everyone. Let's look at some of the questions in our Unit 3 review. A turtle walks around the edge of a circular pond through an angle of 2 radians. The turtle walks a distance of 6 meters. What is the radius of the pond? This question we use the formula S is equal to R theta, where theta is in radians. So we're already given the angle in radians, so we don't have to do any conversions. If it was given in degrees, we'll have to convert the degree to radians by multiplying by pi over 180. So all we need to do here is to plug in this 2 for the radians, 2 for theta. Distance is 6 meters, so S will be equal to 6. So 6 is equal to R times 2. Divide through both sides by 2. We get R is equal to 3. The answer is in meters, and you're done. Part B, what is the area of the sector that corresponds to the distance around the pond traversed by a circle, by a turtle? The formula for area of the sector is A is equal to 1/2 R squared theta, where theta, again, is in radians. If you had degrees, you must convert to radians to use this formula. So let's plug in some numbers. A is equal to 1/2. R we found with 3, so 3 squared times theta. Theta was given was 2. So just multiply these out, the 2's. Undo each other right here. 1/2 times 2 is 1. The 3 squared, so your answer will be 9. This is a meter squared. Okay, so that's your answer. Let's look at question 5. 5 says real number t corresponds to the point P, negative 3 radical 5 over 7, comma 2 radical 7 on the unit circle. Now, just a quick check. On the unit circle, x squared plus y squared is equal to 1. So let's plug in negative 3 radical 5 over 7 for x and 2 over 7 for y. Calculate that down. We end up with 49 over 49, which is equal to 1. So we've shown it is on the unit circle. If these numbers were not on the unit circle, we'd be working with x squared plus y squared is equal to r squared. Just on the unit circle, r is equal to 1. And you follow the same procedure, find r. And then for your sign, in this case, it is just the y value, or y over 1. If you're not on the unit circle, you'd be doing y over r. So remember these, right? You find the r first. Just like we did with finding the 1 here. Your 1 is your r in the unit circle, and you just use the same sort of procedure. Okay, so in this case, y over 1, which is y, and so you just use the y value. Okay, the cosecant is your inverse of y, reciprocal of y, and that's going to be 7 over 2. Your cosine is your x value. That's going to be 3 radical 5 over 7. But it's a negative. Your secant is going to be 1 over x. So that's going to be 7 over 3 radical 5. And you rationalize that to get 7 radical 5 over 3 times 5, which is 15. And don't forget your negative sign. Okay, the tangent now. So tan of t is equal to y over x. That would be 2 over 7 all over negative 3 radical 5 over 7. So you end up with 2 over negative 3 radical 5, and then you rationalize that, give negative 2 radical 5 over 15. Your cotangent of t is your reciprocal of tan. So it's going to be x over y. And so that's going to be negative 3 radical 5 over 7 over 2 over 7. It's going to be negative 3 radical 5 over 2. Okay, and then that's your cotangent, right? A radial transmission tower 33 feet tall and makes a right angle with the ground. So we sketch a diagram, the 33 feet. The guy wire is attached to the tower 5 feet. It's 5 feet. So it's attached 28 feet from the ground then. And it makes an angle of 36 degrees with the ground. So 36 degrees with the ground. Determine the length of the y. So the length of the y is your L. So let's think of a trig function that we can use. You know, this is our angle 36 degrees. This 28 is on our opposite side of 36, and L is on the hypotenuse. So we are thinking about the opposites over the hypotenuse, so that we're thinking about sine. So sine of 36 degrees is equal to 28 over L. So therefore, L would be equal to 28 with a sine of 36 degrees. And your answer there would be, rounding to 2 decimal places, 47.63 feet. And that's your answer. Number 12, an observer at the top of a 48-foot building measures the angle of depression from the top of a building to a point on the ground. It would be 27 degrees. What is the distance from the base of the building to the point on the ground? Round to the nearest foot. So what we want, after we draw a diagram, the building is 48 feet high. Your angle of depression measured from the horizontal line of sight of the observer is 27 degrees. We want to find this distance right here. So let's look at corresponding angles. That's one way of looking at it. Let's say this Z angle, we have this 27 degrees here. Those are two horizontal lines here. The Z connecting between them makes this angle 27 degrees up here equal to this angle down at the ground, 27 degrees. All right? There are many ways to do this, but we are going to use just by these corresponding angle ideas. Finding this angle, we could have also found this top angle here of the triangle by subtracting the 27 from 90. Okay, but we are doing the corresponding idea here to fill out this angle down the bottom. And so what we have is the angle here, 27 degrees. We have the opposite side, which is 48, and we want to find the adjacent side to that. So opposite and adjacent, we're thinking about tan. So tan of 27 degrees, 27 degrees is equal to 48 over D. So then D would be equal to 48 over tan of 27 degrees. And then that should give you, to the nearest foot, 94 feet. That is your answer. Number 16 says Justin is a sine wave which repeats every 12 minutes, oscillates between -8 and -4, has a maximum at 3 seconds. Write a function of the form g of t is equal to a sine bx plus c plus d for Justin. So what we need to find from this is we need to find the amplitude. We know the amplitude was max minus min over 2. It's going to be -4 minus -8 over 2 is 4 over 2, which gives you 2. So that's the amplitude, right? And that is it in absolute values, by the way. The period is where it repeats once. So a period would be 12. It says repeats every 12 minutes. The phase shift there's no phase shift given, so phase shift is 0. Tells you that it's a sine wave, perfect sine wave seems, right? The vertical shift is equal to max plus min over 2, so that is -4 plus -8 over 2. So we -12 over 2, which is equal to -6. So now we should have enough information, or we have enough information to write our equation. So equation then will be j of t is equal to a, which is 2 sine, we should have found b. All right, let's go back. We find b from the period. So b is equal to, because period was 2 pi over b, so b would be 2 pi over the period. It's going to be 2 pi over 12 equal to pi over 6. So it's going to be pi over 6 x. And then c we found from this phase shift. If the phase shift was 0, and the phase shift was equal to -c over b, so 0 is equal to -c over b. So c would be b times 0, which means that c equals 0. So plus c, which would be like plus 0. So don't have to write it. And then plus d, d is -6, so that's -6. And we are done. That's the answer for